Hey everyone, welcome to Weld.com. I'm Minka. Today I'm going to show you guys what I used to do. Basically it was a module got sat in the side of the ground and cement went poured on top of it. So today I'm going to be showing you a partial joint penetration. It's going to be a single V groove on carbon steel plate, A36, 3/4 inch steel plate. Total angle going to be 60 degrees beveled, 30 degrees on one side and 30 on the other side. We're going to be doing oxy fuel cut that with bevel on an automation system. The second thing, we're going to be doing a flux core weld with 045 is going to be the root, and then we're going to step it up to 116 so we can get done real quick and move on. That's going to be on an ESOB 205 we're going to be doing that on. Then final is we're going to be flipping it over, and Jason's going to be doing a back gouge, because the reason we're doing back gouge because it's going to be shut all the way. We ain't going to ever get penetration, so Redbeard's going to back gouge that, and then he's going to flux core that out with 052 or 116. So let's get to it. First, we're going to be basically prepping the plate with a torch, oxy fuel. We're going to be setting the torch at 30 degrees. So that's how they get 60 degrees including angle, 30 and 30 right here. Then we're going to weld it up with flux core. So I'm just going to run 045 for the first couple passes, then I'm going to step it up to 116 so I can weld it out pretty quickly. Then we're going to flip over the plate and we're going to do a U groove. Back gouge, like this says back gouge right here. Here's your back gouge. You can take a grinder, carbon arc, gouge it with a plasma. Today we're going to be showing you how to do it with a carbon arc automation system. So that's how we're going to do it. Then we would weld it up with flux core. And that's it, guys. So let's go ahead. I'll show you how to prep up the material with oxy fuel. So we're going to be running a Ranger 225. That's going to be powering our ESOB 285 over there. Never start a generator up with a cord plugged in because something could be on there, and when you start it, it's not going to have enough power to start the machine, and it could eventually burn up the motor. So first thing, always make sure it's unplugged. Check your oil and check your gas. Next, pull this out, start it, let it run a little bit, slowly push it in. Now bring it over here, let it warm up. You'll hear it calm down a little bit. This is when I let it warm up. I'll go get my stuff ready, go get my tools out. I want to let that motor warm up because it might be negative 30 degrees out. The reason you want to let it warm up because that viscosity of that oil is so thick. You want to thin it up so it gets everything lubricated really good. So let it warm up. When you come back, if you want to run it on high, I always leave it on high idle. So I flip it on high idle because I want my equipment to start up, not like have a little delay to it. And I plug all this stuff in. And we're going to be running off of 220 and two 110s here. All right, so let's get to it. All right, we're cutting 3/4 inch metal on the oxy fuel tip. I choose a tip number 2. I know tip number 2 is good to 1 inch because when we're cutting at an angle, 30 degrees, well, that piece of that metal is going to get longer because we're cutting it. So you do a 1, it's only good for 3/4 inch. And I'm going to be bigger than 3/4 inch. So my pressures are going to be 35 to 40 on your number 2 tip on oxy fuel. Then your acetylene is between 4 to 6 PSI on the Victor torches and Victor's oxy fuel tip. So we're going to go ahead and jump into it, show you how to cut this. But the most important step is plug your fan in and make sure you're cool and not staying overheated or nothing. So my travel speed's set to 14, so I'm going to go ahead and light this. I'm going to put my gloves on first. See how it gaps out right there? So I close my acetylene down a little bit. So I know that's my max on my tip. Then I open my oxygen up. Then I go to a neutral flame. Then I do my oxygen jet. See how it got not neutral anymore? So you want to grab your oxygen and adjust that. All right? Then I relax it, and that's it. All right, we're gonna bring it to the edge of the metal right here. All right, so I like my distance of my cones to the base metal, so I'm good. I'm gonna leave it just like that. So we're gonna look right here very closely. We wanna wait and let that metal warm up a little bit. We wanna get cherry orange. It's almost there. Then we're gonna go ahead and hit this oxygen jet. And the main thing is make sure you're looking down here, you're going all the way through. Make sure you got sparks coming down the bottom, and make sure you're not touching right here. Your cones are not touching that plate. Make sure there's no gas line cords right here, nothing. You got something protecting the cement. Make sure your cords are not messed up right here, because once it starts moving, you got to pay attention to that stuff. You can see that moisture coming out of the plate. See it right here? We could have did some dry passes with this flit to warm up the plate, get all that moisture out. It'll even cut a little bit better. All right, I'm just setting this on here. And we want to look through and make sure there's no gap. And tighten this up. And we got to be 30 degrees. So it'll be 90, 100, 120. So that's 30 degrees away from 90. So 120. So we're good. That came out perfect. Good clean cut. We don't have no gouges in this. This is a good example of a perfect cut. Not to brag, but we're not overheating our metal. If you see it here on the top part, there's no overheating. Like it would, the edge of the top of the plate would just roll over and be melted a little bit. We weren't running too slow. We wouldn't have a massive amount of dross in here or anything. Me and camera guy's gonna lift this plate off. We're gonna put this plate and put it over here on a piece of angles, then we're gonna just throw our other plate up here, cut the same thing, then we're gonna go ahead and clean up with the grinder. So you see here, there's a little gap right here. It's about a 1/4 inch. So there's a couple reasons that happens. Well, metal moves all the time. And sometimes you can't clamp stuff down. Stuff is going to bow on you. Stuff is going to move on you. The track moved on me when I was cutting in the middle. It moved a little bit. But I'm going to show you how to fix it, the remedy. So this is normal. It will happen to you. So I'm going to show you how to fix it. Hey, helper, come here. Got a job for you. Yeah, what's up? What's up, boss? Guess what? It's your time to shine, buddy. This again? So you want to basically bring each end back where it's touching. You want to bring them back and grind them. Grind them back a little bit. Grind this one back 1/8 inch, grind that one back 1/8 inch. If you want to, you could jump on that side and do the same thing. Then we just keep checking it until I'll get about 1/8 inch away. Then I'll just keep checking it, and we're going to just keep trying it over and over. See how it reduced it already a little bit? So if you're not good at it yet, you basically mark. So we're touching right here for sure, and we're getting tight right here. So we're gonna back this grind up to about right here. We're gonna continue grinding this out right here. All right, so let's go ahead and tackle that. Probably another 5 more minutes, and then we're good. All right, I'm just walking up to this machine. Look at our parameters. I'm running 045. 730 wire. So that's flux core with 75/25. So I'm gonna set my bolts at about 25.5. So I'm gonna go ahead and set my bolts. Might tweak it up and down a little bit, probably tweak it up more up. Then my wire feed speed, I like to run about 275 to 300. We'll keep it around 280 for now. Everything else I like. So we're gonna go ahead and back the machine and make sure our gas is hooked up right. So let's go ahead and take a look. All right, I got a little quick disconnects here. These are nice because we're always changing gas around the shop. So I gotta go over here and find out which one's MIG and TIG. So that one's MIG. I'll push this in there. Lock this one down. All right, we're gonna turn our gas on, turn it on all the way. There's a double seat here. You gotta open it all the way. And I run about 45 CFH. So you wanna pull the trigger or hit your perk button and watch your regulator go up to CFH. Actually, these new ones are nice. So you just sit here and actually just go like this. Oops, you gotta put that on better than that. Keep on rolling. All right, let's do this again. We're gonna set this at 45 CFH. We gotta make sure our gas is right. Argon 75 and a carbon dioxide 25, because that's what the recommendation is for this wire. All right, we're gonna tack it here on this side. We're gonna walk down there and tack it. We're gonna flip it over. And then we're gonna get our clamps and start pulling it together to get that 3/16 1/4 inch gap out. Don't look down here, we're looking right here. See how we got this gap basically closed up? So we're gonna put probably a tack right here and put probably another tack right here. So I'm gonna put a big fat tack right here. Let that cool down a little bit before you release your clamp. All right, not to bore you guys, I'm gonna go ahead and just do this all the way down. Then we'll show you guys the after. So we got the gap out. Guys, I didn't leave no mistakes out or nothing. I didn't hide nothing off camera. This is how you fit a piece of metal together and get your mistakes out. So I like to leave everything on camera so you guys can see it and learn from my mistakes. All right, so our next step is, before we call the inspector over, we need to get rid of that spatter, BBs and everything, and feather our tacks in. If you have a cracked tack or a broken tack, you gotta grind that tack out completely before you call your inspector over. I like switching over this thin wheel. It's a pipeline or Weiler because I can get in here pretty good and get these BBs off. So it's all looking good. We're almost to the last step, guys. We gotta go inside, hook up with Jason. He's drawing up the strong backs. If you don't know what the strong backs are, stick around and we're gonna show you. Jason just cut these strong backs out. Jason, Redbeard, tell the audience what a strong back is.
So essentially what a strong back is just a piece of material. We cut it out almost into like a horseshoe type fashion. And what that allows us to do is we're going to weld this to the back side of that weld so it doesn't turn into a banana while we're welding it. So obviously if we had longer sheets, longer sections, we wouldn't have to put strong backs in there. But since we're replicating a much wider area, we want to keep it from curling over. So as you start welding on that piece, it's going to want to, the heat's going to want to, or the material's going to want to follow the heat. So it's going to start rolling up, you know, especially when you start putting multi-passes in there. We'll weld these on the back side. I figure every couple of foot we have 4 of them. That should keep it from curling up. So
awesome.
Let's go ahead and tack them on there.
So I'm running 045. We're getting it all set up and basically doing a dry run all the way down. I pulled measurements here. That got me pretty close. But the dry run and keeping your wire in the middle of the joint is going to be the best way. So I'm doing a little side-to-side pause on the side of the bevel for about 1 second. And we're just going to do like a little weave, like a Z weave. And just keep running back and forth all the way to the end of the joint. Then we're going to jump up to 1/16. We want that big wire to get done fast. We don't want to be spinning all day on this joint, so let's go ahead and get it done. All right, let's see how it turned out. So we're gonna go ahead and just wire wheel this. All right, so we got this first pass in. We're gonna switch over to 1/16 so we get moving faster. So it's 730 select arc, 7525, still the same stuff. We're just gonna up our volts and up our amps because we're running bigger size wire. So hopefully we get one more pass in to flush, then another pass will give us to 1/8 or less. And that's what we want. And so let's go ahead and do the change out. All right, we got the wire finally switched over to 1/16. We kind of like messed around a little bit. It went from light to dark, you noticed. So let's get going, all right? Let's go and weld. We're out here welding a little bit. Here's the crew. Look at that. There's everybody right there. Doing a little automation welding. It's purring like kitten. It's doing good. Really good. Purring good. All right, I think I'm gonna use the restroom, guys. Go make me some coffee. Every morning, 6 a.m. July 4th, they always do buy one, get, what is it, half off on the coffees.
Hey Mike, it's watching the art.
It's watching itself. It's all good. I told camera guy earlier, I was like, man, we need to put Redbeard this side facing this side so we can see the scene and everything. So we want that good looking guy over there facing. You know what I mean? It's got the YouTube. I know. Hey, that's a good looking wart right there, man. That's a good looking guy.
How far outside of the bevel did it go?
Nothing. Nice. You guys will see the results after this is done. Perfect. I just had to speed it up a little bit because we went from that low spot. Remember that low spot when we did that transition? So I had to speed it up a little bit because it's flushing out a little bit. That's it. We're good. Easy money. Watch out! Ah, damn it. I was trying to scare you guys. Choo choo! That's it. That's what you call a golden arm right there. All right, that's our last fill pass. We're ready for the cap. We're gonna chip it off, call the inspector over there, and he's gonna look at it with the flashlight. Then we're gonna go ahead and do the last pass.
All right, Mike, looks good. We're about a 16th inch below the surface, so we should be able to throw one more pass on there and hit that flush to 1/8 inch cap.
All right, let's cap this baby out. Camera guy's been waiting all day. She's so pretty back here. Look at that snake peel. All right, we're gonna check this out. So let's see what this bad boy looks like. Oh my God, that is one sexy, man, that is one sexy weld. All right, that's it on my part. Jason's gonna take over. He's going to flip over the plate. He's gonna show you how to remove the strong backs. Then he's gonna back gouge it and show you guys back gouging it with jointed carbons, a 1/2 inch. And that's it. Then he's gonna weld it up. And that's it on my part. He's gonna close it out. And I'll turn you over to the master, Jason Becker.
All right, guys, it's day 2. So Mike welded everything out last night. We're gonna go ahead and flip this over, knock the dogs off, and get this thing prepped and set up to run carbon arc gouging. So we're actually gonna use a mechanized or automated arc gouging process. We're gonna use some 5/8 carbon, and we're gonna use this DC 1000 because we're gonna be hitting at about 1,000 to 1,100 amps. So let's go ahead and get this thing flipped over and get it set up. Hey, cameraman, come on in here. So you guys can actually see the penetration that we got in here, okay? So what we're gonna do is, it's not 100% all the way through. We've got it in some spots, but just not others. So we're gonna go ahead, that's why we're gonna take that back gouge, and we're just gonna clean that down to sound metal to where we've got a good even profile, and then we'll be able to fill this up, and then when we do the cut and etch, we'll be able to actually show you the weld profile on the inside and where the two welds are gonna overlap from one side to the other. All right, so we got everything set up. We're gonna go ahead and get ready to run that. Before we get into that, I kind of wanted to show you how these exactly work. These are called jointed carbon electrodes. So jointed meaning I can actually stack these. So as the machine is going down the track, I can stack additional pieces and just continue on one after another. So it's a continuous feeding process. So as long as you have enough track and rods, you can just keep running this right down the seam. I mean, here we're only using an 8-foot stick. But if you had 20, 30 feet you had to go, you wouldn't have any problem doing that. The operator's just gonna continuously stack these in here. So we'll go ahead and fire everything up and let's do some arc gouging. We're gonna go ahead and we're gonna run about 850 amps, probably a little bit high, maybe a little bit higher. We're gonna be using the DC 1000 again, so thanks again to ReadyArc for hooking us up with this piece of equipment as well as a generator to run it. So let's go ahead, we'll fire everything up and we'll get to it. All right, so we got the groove all gouged out. The next thing I'm gonna do is I'm gonna break everything down, get it out of my way. I'm gonna take and clean up all the dross that's on here, and then I wanna go through with a grinder. I'm probably gonna use a pipe liner because I can use that on the edge. So I'm gonna use the Weiler pipe liner and just clean that groove out. I wanna clean up any carbon deposits because if I weld over it as is, you know, even after I clean it up a little bit without a grinder, I'm gonna get hard brittle zones in that area. So anytime you do carbon arc cutting, you wanna make sure to clean it up with a grinder, get rid of the carbon deposits before you weld, because hard brittle zones is something we don't want in our material. So we'll go ahead and get this cleaned up and set up the bug-o, and then we'll go ahead and weld it out. All right, so when we set the machine up on the pendant, we actually set the depth for 1/8 inch because, you know, when Mike originally welded out, it was knife edge. So we didn't have to penetrate too far into it to get to the previous weld. So we're back down to sound metal. I just want to see how accurate that piece of equipment is. So I'm right at 1/8. It's just the arc air folks said that it's accurate within 20 thousandths of an inch. So that's pretty damn close for setting it at 1/8 inch. We got just what we were looking for. I got the surface cleaned up. Now what I'm gonna do is just go through and clean out the root just a little bit, not to get deeper penetration into it, but to just clean out the carbon deposits that are in there, as well as I had a misfire back here due to operator error. I'm gonna clean that up and just kind of match that depth. Same thing at the front. You know, I've never run this system before, so it's kind of a learning curve for me, but I mean, aside from the 2 hiccups I had there, it ran pretty clean, ran pretty true. It's very simple to operate. So I'm gonna go ahead and clean that stuff up real quick. All right, so for this, we're gonna use the 1/16 diameter Select Arc 730 wire, running about 314 inches a minute, 27.5 volts. And we're gonna try and do this in about 2 passes. All right, so under the hood, it looked like it laid in there pretty well. Let's go ahead and take the slag off and see what we got underneath. You know them pythons are illegal in Florida. All right, she looks good. Let's see if she'll dance. So above flush, but less than 8, so I'm about 1/16 of an inch. So laid in there nice and smooth, good weld overall. We're gonna go ahead and cut a section of it out, do a cut and etch, and then show you the results. All right, so as you can see, this is the original V right here. And then here's the where the gouging occurred. And here's the final pass. Sorry, here's the final pass of that cap. So you can actually see the 2 different bead profiles. We got 100% weld penetration in here, 100% joint penetration. Looks to me that we're off just a little bit from our center line, but overall we got full penetration through the joint. Everything is solid. We do have a small slag inclusion right here in this area, But if I was to whip out the code book, I would say that would be within specs for this small area right here. You're allowed a little bit of tolerance in that. So overall, that's pretty much how the process is performed, doing a back gouge with carbon arc on an automated system anyway, and then following that up with a automated weld track. All right, guys, so hopefully you were able to learn a little bit about the automated carbon arc gouging process, as well as doing different types of bevels on joints and still coming up with a complete joint penetration in the end. Learned a little bit for some of you that haven't seen it before about how the process works to do a cut and etch. Hope you guys enjoyed the video. Hope you learned something along the way. Remember, if you guys have a video request, something you're having problems with, go ahead and drop it down in the comment section or hit us up on the website, Weld.com. Imagine that. Appreciate you guys watching. Don't forget to like and subscribe. And until next time, make every weld better than your last.